Alright, this is Max. I made an amplifier chip and it works very simply. So I've got a 9-volt source right here, and I've got right over here a Bluetooth receiver so I don't have to like plug my phone in. Anyway, what happens is I will put in a 9-volt signal in through here, and you see with my terminals what I did was I have a common ground through here, or common negative, and what it does is it connects all of the negative terminals together because I just have so many. Okay, so once I have those, what I do is I have the input signal coming in from here to right here, and it pushes the signal through. You see I have two of them. It does stereo because what I have over here is called a dual potentiometer. When I turn this, it increases or reduces the resistance on a resistor that I have in here. What that does is it either sends all of my input signal to the ground, or it sends a bunch of it over to some resistors that I have hooked up right here. You see these little green mylar resistors. Now what those do is they filter out any noise that would be made by any voltage changes right here, because capacitors resist voltage spikes and dips. So any noise that would happen by turning this up or down would be reduced or filtered out by these capacitors. That gets pushed into this circuit right here. Now, what this does, it's an amplifier circuit. Power comes in through this pin you see right here, right? And it goes to this top pin, that's pin number 1. Okay, or yeah, that's the input voltage pin right here, pin 16. Because it goes 1 through 8, and then you have 9 through 16 right here. So what happens is it comes in to here and here, and then it goes through, and pretty much this amplifies the signal that I send in from the right here with any voltage and power from the source. So a lower voltage source will amplify this less. So when I send this out, I send it out of here and here, right here. So what happens is what I've got right here comes out to this little junction right here, and then I have right here a capacitor on the other side with a value of 100 microfarads, and what that does is it's a little bootstrapper, increases the impedance or impedance of the everything going into here, and I have one on the other side as well, and these are identical. And then I also have, once it's met at this node, it can exit one of two ways. The first is by going to right here, which sends it to a 470 microfarad capacitor, which goes out to the speakers right here. And then the other one is right here, right there, and that is a 0.15 microfarad capacitor, and that is for signal filtering. What it does is, if I reduce that value, it'll increase the low frequency cutoff on my output sound. Basically, that means that I'll lose all my deep bass, and I don't want to do that. And then I also hook a few of these into the ground down here, just as I was told. If I don't do that, then it'll increase feedback. It'll basically just fry some of the circuits if I'm just, or it'll fry some of my capacitors. I don't do that. But I had to make sure that they were properly grounded before I did any of this. Or it could make it sound bad. Give me some feedback, that kind of stuff. So after it goes through the speaker, which I have down here and here, then it'll come in to the ground. So it's a very basic thing. So let's see it in action. So I'm going to come over here. I'm going to turn on some music. See, I had it turned up way too much. There we go. So you can see as I turn this, it reduces or raises the sound level. It's pretty cool. Yep. So you can see that that is working out right now. So these capacitors, I'll show you again, this is what I'm talking about. These are the 470 microfarads that push out to the speaker, and then I have right here the capacitors that would, oh, if I wobble the wire, it'll do that to me. Let me pause that. Okay, so yeah, that looks right. I have these right here, these three go out to here. That's for the frequency cutoff. That one right there is as well. You probably don't see that. I used the ceramic one instead. I tried to see the difference between the ceramic and the mylar. I heard that ceramic ones are terrible for sound, but they really don't matter. They have similar nominal values, actually the same nominal value for each one. And then what I have over here are 100 microfarad capacitors that hook into, I'll show you, they hook into some of these pins down here, and they basically do a similar thing. They affect the impedance. They can also affect any frequency stability or ripple rejection. If there's any degradation in the signal at a low frequency or low voltage, you know, that can help stabilize some of those. Let's see where it goes to. It goes to right here and here, yeah. So any feedback, any of that kind of stuff, it would just sort out. So if you have any questions, I can answer them, or if you want to know if you tried putting one of these together and it wouldn't work, I can help you out with some troubleshooting tips.